What the first derivative tells us. Suppose that a function f has a derivative at every point of x, an interval 1 I, then f increases of I if x prime to x is greater than to 0 for all x in I. F decreases if I if f prime x is less than to 0 for all x in I. What this means? In trigonometric terms, the first derivative tells us the differentiable functions increase on intervals where their graphs have positive slopes and decrease on intervals where their graphs have negative slope. What happens if the first derivative is 0? When the first derivative is 0, a derivative has the intermediate value property on any interval on which it is defined. It will take on the value 0 when it changes sign over the interval. Thus, when the derivative changes signs on an interval, the graph of f of x must have a horizontal tangent. However, a derivative need not change sign every time it is 0 considered. Y is equal to x raised to 3. The derivative is y prime is equal to x 3x raised to 2. The derivative is 0 at the origin but position of both sides of the origin. Relative maxima and minima. If the derivative changes sign, there may be a local max and maximum and minimum as shown here. More in this later. So this is the given example. Concavity. Concave down spill water. Concave up holds water. The graph of y is equal to y f prime in concave down of any interval where y prime is less than to 0 and concave up on any interval where y second derivative is greater than to 0. Points of inflation. A point of the curve where the concavity changes is called a point of inflection. If the second derivative is 0, for some x, we may be able to find a point of inflection. If I is possible for the second derivative to be 0 at a point that is not a point of inflection. A point of inflection may occur where the second derivative fails to exist. Relative extrema. Let f of x be defined on an interval I and let x sub 0 be in 1. 1. If f prime f of x has a relative extremum at x is equal to x raised to 0, then either f prime of x is equal to 0 if f or f is not differentiable at x is equal to x raised x base 0. Values number 2. Values at which the derivative is 0 at 0 base to x base 0 or at which f is not differentiable at x is equal to x base 0 are called critical numbers. Number 3. If f is defined of an open interval, its relative extrema occur at critical numbers. First, the first derivative at relative extrema. This is what happened around the point of x base 0. So this is the left side, right side, and third sol. That would be all. Thank you.